Welcome to day 11 of Advent of Code. I'll be programming in Liquid Haskell, a extension that adds refinement types. So refinement types let you say more things than an ordinary type would, and hopefully be able to prove that your implementation is correct, or at least safe. So we've got a couple minutes to go here. Switch over to screen share. Oh, I did want to mention one thing I ran into in a previous stream is this error, which I reported on the Slack. It did not know that the tuple 00 was a pair of ints. The inferred type does not match. And one of the implementers says, one of the authors says, there's a liquid flag that we can use. So I might try that if we run into it again. And we're all ready. All right. Oh my goodness. All right, well, to parse this input, let's take a look. I mean, it's got a structure that, how regular can it be? Let's look at 3L input. So you just need multiplication and addition. So there are few enough monkeys here that we can just hard code them in. So I'm not going to worry about parsing this text at all. So let's just copy this in and decide how we're going to represent it. All right, so I'm going to find a record. To be honest, I still don't know whether we can. I still don't know what the normal Haskell conventions are for like a record. Like, do you come? One of these has to be a bogus name, and I want them both to be monkey. Like, what do ordinary people do? We call it M, the constructor M. So items, just a list of integers. Test is always divisibility, so we can be more restrictive there. I don't think in liquid Haskell we could say, hey, this function has to be a divisibility check. That sort of thing is uncomputable, let alone not within the specification language. So let's give each monkey a number. It's not really necessary, but so what I would kind of like to do is bound all these by some variable. I don't, because we're going to look things up in the matrix, we'd like to, in the array, we'd like to know that it's in bound. Liquid Haskell will yell at us if it's not, so I'd like to be able to say something about these types. And so if I do that, then I'm going to be passing the max around everywhere. All right, let's, all right, we didn't do the operation. Express, we got a square, but, all right, let's see if we can write a specification for that type. So we'll use the special liquid Haskell comment marker. Yeah, see this is the problem I ran into before. So not sure we can get liquid Haskell to accept. All right, I know what we can do. So we can create a subtype in the specification of the monkey class that limits all these things and use that. So this needs to be a non-negative number. So we'll call this new type a monkey in range. So given the maximum type, so this is a monkey where it's making these all greater than or equal to 0. Greater than or equal to 0 is just mat. Positive isn't part of the standard library, though, I think. All right, so the number m has to be less than or equal to x, and the if true m has to be less than or equal to x, and the if false m. What do we want? We want the less than or equal to, or the all right, so let's define the operation all right, so if we're doing this in imperative fashion, we could just set, create a bunch of monkeys and go in and modify their items. We can't do that, or at least I don't know how to do that in Haskell, which is not at all the same thing. So what I'm going to do is write a function that given a monkey works through all its items and returns a description of where those items end up. And let me just okay, so they go in order. All right. So turn goes from a monkey to do I want a data type or just a pair? It can be both. I'm going to be really sick of typing monkey, I can tell. It's a pair from Yeah, we're gonna have to end up passing the max around everywhere, which I don't love. If we only solved one problem, we could then we could just hard code the maximum everywhere. But without that, I think the only way to do it is to pass it around. So this function is from our maximum to a monkey of that maximum type, and it returns a single one, but a list of things with that same bound. In type definitions, the capital letter is for values, and small letters are reserved for type variables. So that's why you have to do this sort of confusing capital X here, and then I used small x here. I guess I don't think I could use capital X here. All right. So the reading suggested after each monkey inspects an item, but before it tests your worry level, your worry level is divided by 3 and rounded down. Okay. It looks like order is important, but I'm not sure why. All right. So we're going to map worry over the items, where worry equals apply the worry to item is apply the operation to the item. Why is it complaining already? Oh. Apply the operation to the item and then divide by 3, and then if worry mod, hello, welcome. I realize I'm not comfortable with the language, but I do wonder why it takes me so long. It's like 20 minutes in, and we're just barely doing the thing here. I think too much, and I haven't used Haskell in a few years. I still don't always pronounce it to rhyme with rascal, which I understand is the correct pronunciation. So if worry mod m equals 0, then we return, we just return new worry, comma, if new worry mod m equals 0, then true destination, else the false destination. All right, that wasn't so bad. And all right, I hate that it warns me about doing this. Great. I've heard both good and bad things about Haskell. I really like the typing system. I like functional languages. What I've heard, and this was my experience using it before, that when things go bad, it's kind of hard to debug. You can't just, maybe that's changed, but I'm curious if that was your experience learning Haskell in your class. So, all right, I think it's convinced all the types are correct, which is good. That parameter doesn't actually do anything. All right. So now we need a function to redistribute the items among the monkeys. So let's call it distribute. Don't have to write the spec yet. So we're going to take a list of monkeys and this list and return a new list of monkeys. Do we need to build all right, so there's two ways to go about it. One is we can iterate through this list and find the monkey in the list and update it. That's going to be a pain in the ass because I have to break the list apart and add onto the list and put it back together. Okay, good. Well, the bad news is Liquid Haskell has its own set of error messages, not in addition to the ones GHCI gives, and they're not necessarily clear. All right, so one option is work our way through the list. I don't want to do that, so I'm going to work through a monkey at a time and pick the things off the list that belong to it. So we should be able to write that fairly easily. It's still sort of an ugly n squared process, but I don't think that will harm us. So bunch of monkeys, a bunch of destinations. Right. So that's going to be, let's take this monkey apart. All we care about is items. All right, well then, is there a Haskell way to update a record shorthand way? Okay. Lenses. What is a lens? I don't understand this at all. That is going to take some reading. Let's try this. So I've changed my mind on that. All right, so we're gonna do M, but with items equals new items, which we haven't defined yet, concatenated onto distribute the rest to the same list of destinations. We don't need to take things off the list. We'll just throw it away when we're done with it. Where the new items equals filtered and to me. All right, so new items. There, that works. Oh, yeah. To me is item then destination equals no, we need to map. Second. We only want to put items, not the whole list. So the second is all right. Gotta be consistent here. First is the item. We should probably just write some functions for that. All right. So this is destination equals which number monkey I am. So that is number M. And of course, when we run out, it's just the end of the list. So let's write our specification. So we've got integer, we got a list of monkeys bounded by that. We've got a list of monkey items and return that, and let's make the additional guarantee that this list is the same length. This should be a length preserving operation. We'd like to say more than that, right? We'd like to say that all the items appeared in the right place, but I don't see an easy way forward on that. Distribute. Let me do the type just so you can make the recursive call. All right. So let's see, we haven't gotten rid of the items. Oh, we can't drive a show because we got this operation in there. All right. Do a little debug helper here. Can't do the operation. I don't care about the, yeah, that's all I really care about. So what is the syntax to say this is our show method? Oh. Now, something's wrong here. Don't know what it is. Oh. Expected kind K0 to star, but monkey has kind star. The source code. No. All right. I saw this in the build yourself a scheme tutorial. Instance show. All right. Yeah, I'm not strong on classes yet. All right. So round, we're going to take the maximum. We're going to take yeah. So Liquid Haskell is a extension that adds refinement types to Haskell's type system. So this is an example of refinement type here, that this is not just any list, but it's a list that has additional properties attached to it. And so Liquid Haskell checks those properties while it's doing type checking. And so the place that'll come up most is, the bang bang operator is augmented in Liquid Haskell. And I think I can find that. Second. Right, so the bang bang operator is augmented with a type that says, oh, this can't just be any integer or numeric type. It has to be one that's greater than or equal to 0 and less than the length of the list, or other foldable you're applying it to. I guess this is only list. And if you don't satisfy that by explicitly doing the check or having carried that refinement type along, then you'll get a compiler error, because Liquid Haskell only allows accesses that are provably safe. All right, so we're going to take our list of monkeys and we're going to return a new list of monkeys. Now we're going to return, so we're going to have to loop. In fact, let's put in a type here. So we have to give the entire. Oh no, that's not going to work because we did it recursively. So that's bogus. That's what we want at the top level, but it's not true at every recursive call. I'm just going to break this into two parts. This is almost what we did here, but not quite. So maximum and which monkey it is, and okay, so we're going to destinations equals calculate the destination, then we're going to reset that monkey's list. Oh, this is the part I hate. We're pulling that. All right. All right. It's too many let statements, but it's all right. So we're going to take that monkey and empty out its lists. So items equals and then all right. That there's an off by one error here. So let's see, if it's 0, then we want to take 0 and put this in its place and drop 1 monkey. All right. And we're going to distribute as destinations over that list. Distribute X other order. Okay. So let's write a specification for that. In fact, why isn't Liquid Haskell yelling at us already? It's probably because there's an error somewhere else. I don't entirely trust FlyMake. Or it might be because we don't have a specification for it. All right. So what we say is front end and then let's show what happens if we don't put in the integer. Did I? All right, I better use less than x throughout here, or I'm going to get super confused. And that way the length of the list can be x. So it says all right, it totally does not believe us. All right, so here's the error I expected to see. Right, we didn't tell it that n was in range, and so it says, hey, you need to give me an integer that's of the type it's in the right range, and you did not. So let's so we can only refer backwards to previous defined variables. So one thing we could do is swap this around. I think that's what I'm going to do. And then say n is a natural number and n is less than x. Okay, so now it's happy about that. Oh, all right, so these need to be the right type. All right, and now it's happy. So it knows about take and drop. So if I had the off by one bug, then it should say, oop, I can't prove that the properties, that's a very complicated error message, but it's basically boiling down to, I can't prove that the length is correct. And after we fix it, error goes away, we can. All right, so write the specification. So we're going to call round n for each n in the range. And the bad news is that no, it's not a map. It's a what is it? Is it a fold? Take, all right, heck with it. I'm just going to write it recursively rather than trying to be clever. So if n equals x, then we're done. Now let's go n plus 1 on 1. All right. So it inferred a type. It's not happy with the type. So we may have to give it a hint. Right, it said, I'll put it up a little bigger. Said, all I know about this is that it's n plus 1, and I think it should be greater than equal to 0 and less than or equal to, that's fine. All right, so it's a termination problem. It says, one of the things like what Haskell checks is did you create an infinite loop? And we may run into a problem here. It doesn't like that specification because it refers to something in the context. Oh, all right. We need to we need the properties that we need at the top level to also be reflected here. All right, so what liquid Haskell assumes proves termination is if the first integer argument goes down, then eventually it'll reach 0 and will terminate. But this goes the opposite way, and so it puts in this constraint that the new value has to be less than the old value, which can be confusing. So we can specify our own termination condition, which is x minus, not condition really, but I didn't like that. Other way around. No, sorry, math is hard. So what we want is something that starts high and goes down to 0. So it should be x minus n. How do we convince it that we know what we're talking about? All right, so the property x minus n plus 1 is less than x minus 1, and it's not provable in the context. So let's give it more context. We say n is greater than or equal to 0, and n is less than or equal to x. I think that should be All right. So now it verified all the properties we wanted at the top level, that the list stays the same, that the list terminates. Great. So we need to count the total number of times each monkey inspects items. So let's add that to our record. I should have done this to start. Now we gotta fix this everywhere. Okay, so its items are empty. I'm going to refactor that. So its items are empty and its count equals plus just do this num items equals when All right, so each time we process a monkey, we update. We not only, it throws all its items away, but we also increment its count. And so we can express that so if you're operating with just one monkey, we could write a specification that the count is non-decreasing. It's harder to do that in this list. I think it's not impossible though. So let's try it. That's what we're here for. So the monkeys in this new list should all have the type that if the number of m equals n, if this is the monkey that we altered, then yeah, this is not going to work because we haven't taught Liquid Haskell that the property that the nth monkey has the nth number. If we could express that, then we could say, okay, this monkey has an extra type that's a conditional statement that says if the numbers match, then the count has to have gone up. I don't see how we can say it with the current set of types, though. That'd be a good property to do. So could we? I mean, we could factor this out into a new function and have the specification for that function encapsulate that property. All right. All right, so let's try it out. So we need to define the, all right, let example, oops, this example is going to be a list of monkeys, and more than that is going to be a list of 4 monkeys. Items are 79 and 98. the operation is old times 19. Modulus check is 23. If true, go to 2. If false, go to 3. I should really put the labels on here. Otherwise, I'm going to get confused for sure. Operation. All right. So this one has 54, 65, 75, 74. Its operation is old plus 6. Modulus 19, 2, and 8. 1697. Old plus 3, 17. There's an error somewhere. I don't see where it is. Missing commas. Not len, but length. So one of the confusing things is that the language of the specification has its own set of functions called measures, or you can import some of the actual Haskell functions, but not all, or you can reflect them in, so the names don't necessarily match. And so one of the decisions they made is that the list length is len in the specification language, even though it's length in the real language. All right. So we're going to do 20 rounds. Let's iterate. Yep. Oh, it's an infinite list. All right. Take 20, iterate the function round for example. Around. Why don't you like it? Oh, all right. Great. Let's see how much trouble we're in. Specification. Okay, next comma there. All right, so all these conditionals are from the take. Maybe we should split it out. So why we told it they were in range and it checked. All right, requires a well-formed monkey. Yes, good. Should know that 4 and 4 are the same. Let's simplify this a little bit. See, that'll give us a clear idea of what the error message actually is complaining about. Let's tell it that the length is 4. I think that might be it. So one of the confusing things is that, Liquid Haskell's trying to match the two. It might throw some type of away, so not everything that it knows is here. All right, we should initialize all the counts to 0. Okay, yes. I have this set up with a helper that reads the file from the command line, but we don't need that. Oops. Nope. I lost my shell session. I figured it. So I guess we're gonna have to check this. I'd hope that I could just look at the values and see that they were all correct, but it did not do that. Right, this should just be a compile time check. Verifying this. Let's see if we can make a compile time check first. All right. Those aren't lists, obviously, they're just individual elements. Oh, well, all right, so there's a typo. So you see how it fails the check, because that is not the correct value. So M1 should be 2 and then 0. All right. Well, something's completely broken. So none of the monkeys got their items. So distribute is bogus. Or it could be that our turn method is wrong, but it's more likely to be this because we got a filter, and so our filter could just be returning bogus. All right, so let's take a look at turn. and distribute example Okay, so we got 2 items. We distributed them both to 3. That worked. So it's this should be fine. So let's just disambiguate it. Try again. Well, let's do let's look at round. Oh, we already know what round is. It's bogus. So let's look at round n x of example 0, and then second one should be n x example. Take that and apply it to 1. Two and then 3. I could be using GHCI to do this. Maybe that's what I should be doing. I'm unhappy. Oh, okay. It is distribute. This should be M items plus new items. All right, so how can we write a specification that prohibits our bug? I mean, that's what I'm really interested in here, is how could I have avoided the bug by having Haskell, liquid Haskell check that I wasn't doing the wrong thing. So we can define a measure on lists of monkeys. So to use a measure, it has to have, it can be recursive, but it can only have one constructor for each, not a problem. So what we want is length of the items in that monkey plus count of items in MS. All right. Instead of giving a specification, we're going to say, oh, I hate this. All right, so the measure needs to be in the specification language, so we have to do it in line. So I'm looking at the liquid Haskell spec. Yeah, so the Haskell functions as measures is what the tutorial does, but we can specify the whole thing here. And then use, oops, still got it backwards. So using that, we can say that count of items in M2 had better equal the count of items in M plus len mi. Right, that's our invariant, is all the items that were there should now still be there, and we're adding in the ones in the list mi. Did it just work? I really doubt that. Yeah. Illegal type specification for GHC.types. Oh, gross. All right, sometimes this is just, I got the type wrong. It doesn't look like it though. So I think part of the problem here is that, so if you look at what's going on here, we tried to create a measure on a list, and list is a built-in type that's parameterized by A, and we specified a measure that only works for one specific type of list, and it's trying to apply it to everything. So to fix that, we could create our own list specifically for carrying monkeys. That is a pain in the ass. Wow, yikes. A lot of the liquid Haskell examples seem to end up like this. It's like redefine everything with your own types so you can get you can get the specifications you want on those types. So it ends up not being very much like programming in Haskell and using all the standard libraries, and more like re-implementing them. So maybe that's a slander, but that is the impression I've gotten so far. So, I mean, it's not like list is hard to implement. It's just would be really nice if we could say only apply this specification to certain sorts of lists. So let me try this. No, this got the same problem. suspect. All right. Yeah, the way I don't really understand the way liquid Haskell works on. So I actually raised a bug similar to this on my first day. I was trying to apply a measure to a pair of ints, and it was being applied to all pairs. So I guess I ran into this already, and I just didn't learn the lesson. All right. Well, I mean, we found the bug. And we even wrote a specification that would find it if we could prove it was. Is there a subset we can prove? Could we prove that, like, so could we prove that the head, it was true for the head of M2? Yeah, there are problems with that. All right, let's try this out. Okay, that looks a lot better. Does that look like what we're told to expect? 500, thrown to monkey 3, thrown to monkey 3, good. Four. Yeah, nope, something's still wrong. So this should have been thrown to 0, and instead it was thrown to 2. Because I still didn't type in the program correctly. If true, all right, 2 and 3, 2 and 0. 1, 3, 0, 1. That's the disadvantage of assembling the program by hand rather than parsing the text, is I introduce my own typos. All right, that looks a lot better. 20, 23, 27. Yeah, got a problem there. 26, where'd that 26 come from? That looks like it. That looks like a typo. Let's double check. 79, 98, 54, 65, 75, 74, 79, 60, 97, 74. Excuse me. Don't like coughing into the live stream. All right, looks good. So let's go back to this. All right, so first 20. Yes. Yeah, our counts aren't right. Okay, this 0 is the opening count, so we need to do 21. We need to do 0 and then 20 more. Or we could do bang bang 20 to just extract that one. 101, 95, 7, 105. Great. Now we gotta put in our real input. So there are 7 monkeys. All right, and we just need to copy them accurately. 59, 74, 74, 65, 86. Old times 19. Test mod 7. Go to either 6 or 2. 1 starts with 62, 84, 72, 91, 68, 78, 51. Its operation is +1. Test divisible by 2. 2 or 0. Okay, 2 starts with 78, 84, 96. The operation is +8. Modulus is 19. Go to 6 or 5. 3 starts with 97, 86. Old. Test is divisible by 3. Go to 1 or 0. +50. Old +6. 13. 3 or 1. We probably should have written a constructor function or something that simplified this. 73, 65, 69, 65, 61. I could also, I guess, copy and paste that in. Is 11, 4, or 7. The operation is plus 5, its mod is 5, 5 or 7, 2 more, 1 more. Counting is a great challenge to me. Three, test mod 17, 3, great. Well, that's a little odd. All right, it's complaining it doesn't know that this infinite list has 21. There's no let's just let's write. We'll assume a type for iterate. So this just says apply the specification existing function, assume it's correct rather than checking it. So the type of iterate is and we're just gonna say assume this list is at least 1 million elements long. All right, so now we'll happily last look up the 21st because we assured it there's at least 21 there. So why if it believes this type, does it not believe this type? All right, because I can't count. Okay. I overshadowed input. That was the problem. So I have variable called input two places. So we need to multiply the two most active. Oh, no. So 35 times 32. That seems low. Yeah. So something's going wrong. So it'd be nice if we could successfully write some specifications to tell us what we'd screwed up. Well, so the most obvious is a transcription error. Two, 72, 91, 68, 71, 51. This one, 2, 2, 0, 6, 6, 5. Three, 1, 0. 4, 50. 6, 13, 31. 73, 65, 69, 65, 51. So that was a small error. Five, 5, 7. right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 1, 32, 33, 34, 35, 36. And there's still 36 at the end. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. No. So definitely got a problem with not maintaining the same number of items. So I guess we should try harder to prove that we don't lose any items in each round. All right, so let's start small. So the length of items should be equal to the length of all right. Is that true? Come up per specification. All right. Liquid Haskell is slow enough to compile that FlyMake often doesn't keep up once the file gets to a reasonable size. All right, great. All right, we're gonna create a new type of list, and we're gonna count the number of items in the list. Not type data. Maybe we should call this a barrel of monkeys rather than a list of monkeys. As I get more tired, my ability to get the brackets in the right order decreases. All right, so add data specification. Why ever so? All right. Yeah, the liquid Haskell specification doesn't like fields without names. All right, so let's create a monkey list out of a normal monkey. Can't do it as a measure though. I'm not sure we actually need a type, but easy enough to describe it. All right, so do we make, what I was thinking is, yeah. Let's just write a version that works on monkey lists. What do you mean it does? Oh. Okay. okay, so the problem is distribute had our restricted type. So we need to make that work here. I think we tried this earlier in the stream and it doesn't work. Monkey IRX. Yeah, that's not gonna work. Use type operators to allow operators in types. No. All right, let's back up. We're gonna make distribute that works only over one size. All right. Distribute to. All right, need to recursively call our same function. All right, so what we want to say is add our additional constraint here, which is that count items to equals count of items n plus len mi. And I don't think it's going to be able to prove this. I think we're going to have to give it a lot of help. And hopefully in the course of proving it, we'll figure out where my stupid bug is, assuming it's in this function at all. It's still running. All right, that would help. All right, so the invariant's got problems, even in the base case, right? It's false in the base case because both those lengths, this have lengths of 0. So yeah, that's a nice invariant at the top level, but it's not true all the way down. So could we rewrite this non-recursively? Well, it is a map operation. Yeah, I don't have a clear plan for how we're going to prove this, or even what we should prove. If we wrote as a map, then we'd have less problem with recursion, but probably more problems proving it, because the invariant just gets pushed down into places where it's less accessible. So right, in order to prove this, we need to know that every element of this is in range, which we do have a type for. This is, but it still might depend on a mathematical proof that we need to write. All right, so what if we simplify it by filtering out, do I have this backwards? No, filters selects the positive, right? Turns those elements that satisfy the predicate, yes. I'm gonna have to give up soon. I don't know that the type of filter is going to be useful either, right? All it says is the length is less than or equal to. So what I was thinking is we could filter to not. We could filter the destination lists. What is the problem now? Oh, sorry, I didn't save. That would help. I had a leftover, had a straight punctuation mark, I think. Oh, it's not. This should be monkey item. Okay, that was the problem there. All right, so now at least the base case is true. But it doesn't believe. All right, so this should be a list with length of less than or equal to. Okay, so now we got the base case. And now I have to prove the hard case. So I'm probably going to have to do it in a couple steps. And it may, again, turn out to be that my bug is somewhere completely different here. So what we need to tell it is that filter to me, okay. So we've got a change in this and a change in this, and they should be equal in magnitude. So let's write a proof of that. And we may just let's assume. All right, let's just write the type. So I'm going to import we may end up having to write our own filter to prove this. What am I looking for there? Import proof combinators. So I'm going to write some proofs. We're going to it's going to be a proof. It's going to be take a filter, a predicate, and a list. And what we want to show is that given the predicate and our list, that filter pred on the list plus filter not dot pred on the list. Does not actually work like that. Yeah, should be fine. Except, okay, equals, all right, so not that, the length of the filter plus length of that equals the length of the original list. Right, that is our useful effect that we need to show our invariant holds. All right, well, we can show it holds on an empty list. Nope, I was right the first time. What's missing is there. All right, so it doesn't like that because filter is not in the proof language. Can I reflect it in? No. All right, so backing up another step. If pred x then x might alter pred x's else. All right, so we can reflect that into the language, I hope. In the type specification. No, I think we're running into the problem of it uses too many GHC types. That this shouldn't be a problem. That where is the chapter I was reading? Right, these these proofs are all using standard lists. So that shouldn't be the problem. Where are all these types coming from? Compound symbol LQ1. Well, I may have to ask the Liquid Haskell Slack for help on this one, because this should be doable. I'm just gonna make sure it's not this causing problems. Yeah, so what I'm trying to do is reflect the definition of my filter up into the specification so that we can prove things about it by using that definition, like the lemma I wrote below. But it's severely unhappy. For reasons that are not easy for me to parse. It seems not to be picking up the type, the name associated with that predicate. It might be a problem that this is a higher order function. What if we go even stupider and say, what if we have a filter that matches on the second element? So if X is P, no, if second X is P, reflect that. No. So whatever, okay, so we need to say, okay, we need to say this method only works for types that have equality. Sure. Wow. I'm going to have to run through the example here. Because we shouldn't need to reflect these other types in there. They should be there already, but all right. So I'm no closer to finding my actual bug. But we know that items are disappearing, and this is the most likely place that they would be going. So, be nice if Liquid Haskell gave us a hand here. And the most obvious thing is if I had not all the numbers present. Yeah, I told you to ignore that. Yeah, I know it doesn't work. So if I was having this problem in Go, I'd pull up the debugger and step through it one at a time. And I wonder, okay, does anybody distribute items to themselves? That seems like an error case. Could easily go wrong, but nobody does. Two. So we fail pretty early. Yeah, there's 36, and by the second round, we've already gone bad. So, Well, that's interesting. That doesn't seem consistent with what we're seeing above. What the heck? Length. All right, so something is different is happening here. I wonder if it's because I use the same. What if it's like because I used the same variable? That would be pretty stupid. Five, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. Really? Really? Something strange went on here. All right. Okay, I don't know for how long I've been held up by all right, can we encode the division as an extra parameter and pipe it through? Destination. All right, so pipe worry all the way through. So this is now iterate. We have to get the 10,000th run. I really have no idea what the problem was. I mean, my theory was it was because I used the same number each let, but put it back that way and it's fine. Oh, it's taking a long time to run here. We need to tell it that worry is a non-zero number. Is there a non-zero? Guess not. It's looking out for us, making sure we don't divide by 0. We could define a list for that. Boy, look at Haskell's really working hard. You can see the solver it spits up in the background, eating up CPU like it's no tomorrow. All right. 5, 2, no, we got some sort of problem. I don't like that we got negative numbers. Um, shouldn't be possible using the set of, right, these are all increasing. So are we, it's kind of silly to be worrying that division by 1 is causing a problem here. But let's just make sure. I suppose it could also be a modulus problem. All right, let's. Fixed position, well, okay. So yeah, it's quite likely that we're getting wraparound. So how are we gonna solve that? I frankly didn't think it would be a problem, but yeah, we're going bad even in the first 1,000. All right, let's swap out. if we can multiply better make worry integer too. Oh, come on. I can't believe I got the yeah, where's that? Don't tell me that liquid Haskell is gonna reject the integer type. It's fine. It's a lot slower. Okay, so I know what we were supposed to do here. We're supposed to calculate the product of all those prime numbers and work modulo that. Because there's no need to actually keep these all around because they just grow real big. But all the divisibility tests will match modulo those. So yeah. All right, so all right, let's replace the integers with ints again. Let's calculate the modulus. Where shall we put it? Yep. Yeah, and so I'm reducing them all via the common modulus, the GCD of all the moduli. I tried throwing integer at the problem. That was too slow. Okay. We could calculate at any point here, but what I'm going to do is write a little function. Okay. All right, let's try that. I'm not sure I got all those straight. Run in size worry modulus. Let's save. Yeah, liquid Haskell is a lot slower to compile than even normal Haskell. So it's running a Z3 the Z3 solver in the background to verify a bunch of properties, and we can actually look at the program it's giving, but that is what makes the compilation so long. It's all the things we said should be true, it's verifying are actually true. It's not as many as I wanted because I got stuck trying to prove some interesting problems when I thought I had a correctness issue that mysteriously disappeared. All right, so did we break part 1? No, that looks good. Okay, all our numbers are positive. Let's check. Five, 2, 1, 6, 6, 5, 2, 3. Looks good. Yep. All right, so we have to multiply these together again. Yes. Well, if I don't have message sounds, I tend not to look over at the chat. So. treatment using Python because I don't want to wait for TCI to compile everything. Hurrah! We're done. All right, so I spent a lot of time trying to come up with a way to prove this invariant when I thought that was the problem, and it all failed. And it's invariant I really would like to be able to prove. I feel like we should be able to do it, and just wow, nothing worked. But it turns out, as far as I can tell, this wasn't my problem. My problem was either either on this side of the keyboard rather than the other side of the keyboard, or I got tripped up by something that I'm still ignorant of. I did use different variables here now, but that didn't really seem to be the problem. So it looks good. I may work on this tomorrow afternoon because this is exactly the sort of invariant we should be able to prove in liquid Haskell. And I could not make any progress on, I tried creating my own list type because working with the raw list type wasn't working. And then reflecting the filter functions, either variety, doesn't help. So I'm missing something about how to do this, because the proofs that are mentioned in the liquid Haskell document work on ordinary lists. So there should be some way to do it. All right. Yep. Chinese remainder theorem helps us. We don't even need, well, it is that, but it's just the injected mapping we need. So, all right. Good night. So the invariant. So I have a function that distributes the items to the monkeys after one of them has juggled them and made the decision and made a list of where they go. I distribute items, and at one point it looked like I was having a problem that items were disappearing, and so I suspect I had a bug in the distribute function here. And so what I was trying to prove is that at the end of the distribute function, the total number of items is unchanged. The items in the monkey's hands after it finishes should be the amount before plus the number that got redistributed from the monkey who is active. So yeah, if you go back in the stream, I spent a lot of time trying to get something of that variety to work, but that turned out not to be the problem. So, good night.